This is the review. For test number 3, believe it or not. Test number 3. And here we go. Question number 1. 5m minus 10 divided by 2 minus m. All right. So this problem, there will be a problem just like it on the actual test. So, I'm really giving you a very, very extraordinary review, which kind of parallels the test. Okay, here's what you do. The first thing you do when you look at any of these problems is you factor whatever you can. This can be factored, this numerator. 5 times m minus 2 divided by 2 minus m. So here's the critical thing right in here. Because if you take the 2 minus m and switch it around to negative m plus 2, and then take out the common factor here of negative 1, so you rewrite this, and you take out the negative 1, and that'll leave you with positive m minus 2. This is standard. This will happen in this particular problem, that you'll be able to, factor it and then see that the factors are very similar, and then rewrite this. So it's, the m is first, take out the common factor, which will be negative 1. Then you get rid of this. And you're left with 5 divided by negative 1, or negative 5. Unfortunately, it's only a 5-point question, but it's still 5 points. You still need to get it right. So just stop me if you have a question. Problem 2. Problem 2, the instructions are to divide. And let me write out what we're doing here. It's 2x squared minus 5x minus 3 divided by 2x squared minus 11x plus 5 divided by x squared plus 2x minus 15 divided by x squared minus 25. Okay, so you write the problem. The next step is to take the second fraction and flip it over. So I'm rewriting the first fraction. And then we multiply x squared minus 25 over x squared plus 2x minus 15. All I did was take this fraction and flip it over. Now it's a factoring problem. Now it just becomes a factoring problem, because you have to factor each of 4 expressions. I like to start with the one that I find to be the easiest, which is the numerator of the second fraction, which would be x minus 5 over x plus 5. Then the denominator, which is 5 and 3 and positive and negative. Now you have to go to these up here. This to me is the easier one to factor. Hard to say why, but there's going to be a positive here, a negative there. Therefore, you're going to have 2 negatives. The only way to get a negative when you add and a positive when you multiply is to have two negatives. And now you know how you're gonna get 11. You're not gonna get 11 by putting the 1 there and the 5 there. Well, actually, the 1 there and the 5 there, right? Because that'll only give you 7. But if you put the 5 here and the 1 here, this will give you -10, -1 is -11. So you have to know how to factor trinomials and binomials and things like this. It's all factoring. I told you this when early on in the semester that chapter 4 is all factoring. You really have to know how to factor. Now this 2x and x. All right. Well, we know that one of them is going to be negative, one's going to be positive. And the good thing is that it's got to be either a 3 or a 1. So let's see how we could do this. Now, you could do it over here. 2x. So you could do it over there and just, say, well, let's see now. How about 1 and 3? But there's no combination that'll give you, I don't think that'll give you. Well, let's see. Yeah, maybe it will. Yeah, it looks like it. -3, +1. This will give you -6. This will give you +1, and that's -5. There it is. I picked the right one. Yeah, that worked. You see, if you do the other one, which would have been 2x and x, and put the 3 and the 1, that wouldn't have worked. There's no way of getting. I mean, you could get a 5x. You could get a 5x. But only if both of the signs are the same. So this is not going to work. And therefore, it has to be the first one, 2x + 1 and x - 3. Okay, that looks pretty good. Now you try to cancel out whatever you possibly can. So you can see that this cancels out with that. You could see that this cancels out with that. And you could see that this cancels out with that. This is close. But they're different. So this is now going to become 2x + 1 divided by 2x - 1. That's going to be the answer to the question. As I said before, it's a factoring problem. If this is a factoring problem, it's all factoring. And then, all you have to remember is when it's division, you flip over the second fraction. And then it's just a factoring problem. Problem number 3. Because there's an awful lot of factoring. We have more factoring. Oh, you know why? Because there's more factoring in this problem than any other problem. Like the next problem I'm looking at is problem number 3, which looks like this. K + 1 over K squared minus KW. And then minus 1 minus W divided by W squared minus KW. I'm just looking back to see if I have the exact question. I'm supposed to. Okay, well, step 1 is to factor. And you're going to factor this as greatest common factoring. See, that's an easy factor. I mean, it's not easy, but it's easier than those trinomials up there. I'll bet you're having the most trouble with these. These are the ones you have trouble with. You can't possibly have trouble with this and this. But I think these are
No, you were right. That's exactly what I'm having trouble with.
Yeah, all right. So we'll spend time on that if we have time. Okay, let's continue. Minus 1 minus W over, now, the common factor here is W. And W minus K. Interesting, right? Because this is W, this is K minus W, you see. This is W minus K. Let's straighten those out, shall we first? Let's first straighten this out. Okay, because this is the same as this, except with that negative sign thing. So I think we ought to straighten that out. So let's get K plus 1 over K times K minus W minus 1 minus W. And then over here, let's make that negative K plus W. All right, so obviously, once again, we could take out a -1 here. So that would become W, take out the -1, and you're left with K minus W. So this problem now becomes K plus 1 over K times K minus W minus 1 minus W over. Now, let's put that negative in front of the W. Okay, so I'm gonna move these around and make this negative W times K minus W.
Turn it into a positive.
Make this a positive. The negative and the negative make that a positive. See? And then we could just simply remove that. And now the problem looks pretty normal. Okay, now the least common denominator. The least common denominator will have a K. It'll have a W. It'll have a K minus W. It will have, and it has to have the same thing here, K, W, K minus W. Okay. This is nothing. This is just an extra line that suddenly got there somehow. Okay, now the object is to get from this fraction to this fraction. So the question is, what is missing here in the denominator that we have in the least first of all, we form the least common denominator based on all the denominator. We have a K there, we need a K there. We have a K minus W, we have a K minus W. We have a W, therefore we need a W. We have a K minus W, but you already have that, so you don't need two of them. You only need one of them. Okay, now what's missing in this fraction in the denominator that we have here? And you could see that it's a W. So therefore, we multiply here by W and the numerator by W. And that will give us W. Now, W times K is W. Well, let's make it KW. To put it in alphabetical order. So KW plus W divided by KW minus K minus W. Here, you look at the old denominator. You look at the new denominator. What's missing? A K. So you're going to multiply by K and by K. And that's going to make this K minus KW. I'll let you look at that to let it soak in. Now, we're gonna put everything over the same denominator. We have the least common denominator, KW times K minus W. And in the numerator, KW plus W plus K minus KW. And now there's only one step left, and that is to recognize that you have a positive KW, a negative KW, and you get rid of them both. And you're left with W plus K, which I think will, since we're keeping everything in alphabetical order, let's just make this K plus W over KW times K minus W. This, I believe, is the answer. Let me review the entire problem. Can I get up that high? No. I'm not without losing the answer. Well, I could still get up that high. But, so this is the original fraction. The first thing I did was factor the denominator. The second thing I did was to recognize that K minus W is very similar to W minus K, except that there's a negative sign that's misplaced. So I rearranged the K and W. I took out the common factor of negative. See, I moved it over there, and then I moved it down here. And I made that negative and that negative into a positive. So I got rid of that negative. Now, the next step was over here, where I created the least common denominator. That's this. This has to have everything the old denominators had. The next step was to multiply by what's missing in the old denominator to get to the new denominator. And I wound up with KW plus W plus K, and so on, and there it is. Next problem is problem number 4. So let's go back up here. Problem number 4. X plus Y over X minus Y minus, an interesting problem, X minus Y over X plus Y divided by XY over X squared minus Y squared. This is a complex fraction. And the idea behind a complex fraction is to simplify it. But first, you look around, you see if anything can be factored. This can be factored. So you wind up with X plus Y over X minus Y. I'm just rewriting what I have in the numerator. I'm factoring X squared minus Y squared, and I'm gonna get X minus Y times X plus Y. Once again, we look for the least common multiple. It's very common. We did it here. We look for the least common multiple. We do it here, and we're going to be doing it in the next problem as well, when we solve the rational equation. So we're going to multiply every single term by the least common multiple, which is right here. So we're going to multiply this by X minus Y, X plus Y, this by, well, didn't allow enough room, but I'm going to try to move that over. X plus Y, X minus Y. That's the next step. Every single fraction gets multiplied by the least common multiple. Because we want to get rid of all these denominators. That's what we're trying to do. So you start at the top left. This cancels out with that. Good. That'll leave us with x plus y times x plus y. Minus. Now here we have x minus y. Now this cancels out with that, x minus y. And here, this cancels out with that, this cancels out with that, and you're left with just xy. So the first step is to just, factor, get rid of all these denominators, and now we want to do all the multiplying. So we're going to now multiply the binomials. X times x is x squared. This is xy, this is xy, so plus 2xy plus y squared minus, let's put that in brackets, because everything that we're about to do gets multiplied by that negative. This is x squared. This is negative 2xy. This is positive y squared over xy. Now I'm going to use that negative, this negative, for this entire expression. So the next step is to rewrite what I have here, x squared plus 2xy plus y squared minus x squared. Negative times negative is positive, 2xy. Negative times positive is negative y squared over xy. The x squared and the negative x squared would become 0. The y squared plus the negative y squared would become 0. And then 2xy plus 2xy is 4xy over xy. And I think you can see what's going to happen now. The x's will drop out, the y's will drop out, and the answer to this whole question is simply 4. I love this problem because you always wind up with this really great answer. After all this work, you're going to wind up with that answer. Y plus 2 over y squared minus y minus 6 times y squared minus 1 equals 0. Step 1, factor everything. The first step is always to look at this type of problem and factor it. So we write the original numerator and we factor y times y minus 1 minus 6 over y minus 1, y plus 1. And that equals 0. Again, the object is to find the least common multiple, so that if we multiply the entire equation by the least common multiple, we'll drop out all the denominators. So we're going to multiply by the y has to be part of the, so let's just over here, let's create the least common multiple. It has to have a y. It has to have a y minus 1. It has to have a y minus one, but that's already there. So we could use the y plus one. All right, now that least common multiple gets multiplied by everything here. So y minus one, y plus one. Y minus one, y plus one. And this is easy. Y minus one, y plus one. And as you can see, in this particular case, this zero, and since there's no denominator here, this zero will make all of that equal to zero. So everything will cancel out. But the rest of it, this cancels out with that. The negatives one cancel out, and you have y plus one times y plus two minus the y's minus one drop out, the y plus one drop out, and you get 6y. And of course, this is equal to 0. So that process did a lot to simplify what we have up here. This will now become y squared plus 3y plus 2 minus 6y equals 0. I multiplied the two binomials. I got this, and I kept that negative 6y. And now I combine like terms, and I get y squared minus 3y plus 2 is equal to 0. And that can be factored pretty easily because this is a 2, this is a 1, negative and negative. Therefore, y is equal to 1, y is equal to 2. That looks like the answers. But we really have to check for extraneous solutions. Whenever you have a fractional equation and you wind up solving for a solution and getting an answer, you must go back and check for extraneous solutions. So the next step would be to put the 1 in here. And you can see that 1 squared is 1. 1 minus 1 is 0. This is an extraneous solution. No good. It even doesn't work here. 1 squared is 1. 1 minus 1 is 0. This is extraneous. Extraneous. Let's let y equal 2 and see what happens. So 2 squared, 4 minus 2 is good. 4 minus 1 is good. So this is valid. The other one is extraneous. The only answer to this problem is y equals 2. All right. So here's problem number 6. It is a graph. It is a graph of a rational function. Now we know that the graph of a rational function, this is what it looks like. This is the parent. This is what the parent looks like. Okay, so the parent will look like that, and indeed, it will look like this. Now, do I ask for the parent? No, I don't ask for the parent. But that's how I start every problem. By looking at with the parent. So this is what it looks like. But that's not what we have. This is what we have. We have g of x equals negative 1 over x minus 5 plus 3. And there's several things we need to know. First of all, we need to know the vertical asymptote. The vertical asymptote will always be x equals the opposite of whatever we have there. So the vertical asymptote is x equals 5. The horizontal asymptote will always be y equals whatever that number is. Well, that's a good start. We also know that there's a negative in front there. When you have a negative in front of a rational function, so when there's a negative, the negative will cause, this is what the negative will do. When it's f of x equals negative 1/2, instead of it being in the first and third quadrants, this is the first quadrant, the second, the third, and the fourth. We go that way. That will do more of that starting next week when we start doing trigonometry. But whenever there's a negative, then the parent function is a reflection. So it'll be in the second quadrant and the fourth quadrant rather than in the first quadrant and the third quadrant. So we know that much so far, and that will be helpful in doing the next part of the problem. So we now draw a graph. The new vertical asymptote will be x equals 5. The horizontal asymptote will be y equals 3. Now we don't even need the old x-axis and y-axis because we have a new set of axes. And whatever we had in the parent function for a negative function, a negative rational function like negative, that'll mean that it'll wind up in here and in here. And that's what this graph will look like. That's what the function will look like, graphed. Now, we're also asked for the domain. The domain will go from negative infinity. Negative infinity. Give myself more room here. I just wanted to. From negative infinity to the vertical asymptote of 5. And then from the vertical asymptote to positive infinity, going out to here. The range, so domain refers to the values of x. The range refers to the values of y, and that will be from negative infinity to 3, and from 3 to infinity. And this is the complete problem from beginning to end. Step 1. Again, factor. Step 1 always seems to be to do the factoring if factoring is part of the problem. See, the previous problem, factoring wasn't part of the problem. Here, of course, it is. That's a positive, that's a negative. Now, this means that this fraction started out looking like this. In other words, a number divided by one of the factors plus a number divided by the other factor. Draw a line. The next step is to say, okay, well, 7x plus 11 is equal to x divided by x minus 7 over x plus 8. That'll be equal to this. And of course, now we want to find the least common multiple so that we could get rid of the denominators. That always seems to be part of a lot of problems here, is finding the least common multiple to get rid of the denominators. So the least common multiple has to be a combination of both of the denominators. Get rid of the x minus 7, get rid of the x plus 8. We wind up with 7x plus 11. Get rid of the x minus 7, we get a times x plus 8. Get rid of the x plus 8, that leaves us with b times x minus 7. Now, the goal is to figure out the value of a and the value of b. And we do that by selecting a value of x that will get rid of this and make it 0. And that will knock out the a, and we can solve for b. And then to let x equal something that'll knock out that fraction, that expression, and that will give us the ability to solve for a. So we create a little bit of a situation here where we let x equal, let's start with the 7. And what is going to happen is that when we substitute this 7 into this expression, this will drop out and it'll give us the ability to solve for a. So we multiply 7 times 7 plus 11 equals a times 7 plus 8 plus b times 7 minus 7. This becomes 49 plus 11 equals 15a, and this just drops out because 7 minus 7 is 0. 0 times b is 0, so this just cancels out. 49 and 11 is 60. Divided by 15. Turn it around, and a is equal to 4. Good. We now know one of them. A is equal to 4. Now we want to get rid of the a so we can solve for b. So we have to let x equal -8. The -8 plus the +8 will cause that to drop out. So x is equal to -8. 7 times -8 plus 11 equals a times -8 plus 8 plus b times -8 minus 7. This drops out because it's 0. This is -56 plus 11 comes out to -45. And that will equal -15b. Divided by -15. and b is equal to 3. So that's what we want to find. We want to find the value of a. We did so. We want to find the value of b. We did so. And now we're ready to put a and b back into this original problem up here. So what we now have is 7x plus 11 divided by x squared plus x minus 56 over 4 over x minus 7 plus 3 over x plus 8. Now, the only way to check this, well, I mean, I guess there's a lot of ways of checking it, but my favorite way is to just cross multiply. 4 times x plus 32. I'm multiplying here. I'm multiplying here. 3x minus 21. This will be 7x. 32 minus 21 is 11. There it is. That's all you need. So the numerators are going to be the same. So that's the check. Okay. The answer to this question is this. Without all these things going on here. Let me get rid of them. So the object in this problem was to take the original, let me go back to the beginning for a moment. Take the original fraction and create a partial fraction. These are called partial fraction decomposition. In other words, we're taking a fraction, decomposing it into its parts. And that's this whole process here. And we wind up with this answer.
Professor, I have a comment.
Good. Go ahead.
Yeah, I got on b equals 4 and a equals 3, but I ended up getting the same answer, but just different letters on each equation.
Okay, but
Doesn't matter, right? Or it does?
that's not the issue. The issue is, did you have this answer?
Yes, I got the exact same answer.
That's all that counts.
All right, thank you.
Sure. In fact, as I was setting up the problem, I'm saying to myself, as I'm setting up this problem, I'm saying to myself, you know, what if students factor this as x plus 8, x minus 7, and decide to put the a over the x plus 8 and the b over the x minus 7? And that's okay. That's fine. As long as this down here, as long as this is the same as I have it, that's the answer. Good question, though. Very, very good question. You're given, so the problem says if f of x is equal to 1 over x minus 3, g of x is equal to 3x minus 1, and h of x is equal to 1 over x squared minus 9. When you turn over the page, you're asked for 4 problems. Okay, so I will tell you right now something very, very well. Let's do the problem. Find the domain of f of x. F of x. Okay. So f of x is 1 over x minus 3. And we want to find the domain. That means we want to know when we can actually put a value of x into this denominator so that it's not equal to 0. So I'm going to say, okay, in other words, x minus 3 cannot equal 0. That's the only problem. The only problem will be, what is x equal so that this fraction is not equal to 0? And the answer is x cannot equal 3. That tells us that if we draw a number line, we must put an open circle around 3. And it's just going to be everything else. It's going to be all this over here going in this direction. You know, to infinity, to negative infinity. So therefore, in interval notation, does it say interval notation? No, but it's, you know, it's interval. I want interval notation, I'll tell you right now. In interval notation, the domain, and really this is how you write a domain. Negative infinity to 3, and then 3 to infinity. This is the domain. You've had a lot of experience with this over the course of the semester. Okay. Second part of the problem. Find f of g of x. Now remember what that means. That means that we want f of g of x, meaning if we write f of x as 1 over x minus 3, what f of g of x means that wherever we see an x, we're going to substitute the g of x up here. So this means that f of g of x, instead of it being x, it's going to be 3x minus 1, because that's what g of x is equal to. So it's going to be 1 over 3x minus 1 minus 3. Which will equal 1 over 3x minus 4. That's it. F of g of x will equal this expression. That's part B. Part C, find the domain of this. So C is find the domain of this expression. So the domain of f of g of x is done the same way we did this. The problem is we don't want 3x minus 4 to equal 0. So we say that must be not equal to 0. And we solve. 3x equals 4. Divide by 3. X is equal to 1 1/3. And from here, we create a number line. Here's the 1 1. Here's 1. Here's 1 1/3. And in interval notation, negative infinity to 1 1/3, 1 1/3 to infinity. And if you wanted to, it could be negative infinity to 4/3 if you didn't want to change it to an improper fraction, to a mixed number rather, 4/3 to infinity. Okay, so either one of these is the answer. So we have, for this problem, 3 parts. You know, you're given You're given three functions. Now we've used these two functions. We haven't used that one, so that's gonna come next. And it's gonna come in the form of asking us, what is f plus h of x? What is f plus h of x? And that means, what is f of x plus h of x? This is the very first thing we did when we were beginning chapter 5. We were doing this type of, we did a lot of, properties of the functions. I think it was chapter 5. May have been chapter 4 now that I think about it, but now I'm not totally sure. But anyway, it's it's f of x, which is 1 over x minus 3, plus h of x, which is 1 over x squared minus 9. And we do this in the regular way by first factoring. Then we create the least common denominator. Here we go again. The least common denominator will be x minus 3 times x plus 3 plus x minus 3, x plus 3. Now, what's missing, this is the same, so we don't do anything. But here, we're missing an x plus 3, so we have to multiply by x plus 3 over x plus 3. And this will be x plus 3. And when you combine the two fractions, you wind up with x plus 4 over x minus 3, x plus 3. If you wanted to consolidate everything, you could write it like that. I have no objection. If you want to be really thorough, you could say f plus h of x is equal to x over x squared minus 9. Excuse me, x plus 4. And that's problem number 8. A lot of parts to it, but it's not a difficult problem. And now we're going to do problem number 9, which is to find the inverse. Find the inverse of f of x, and prove that f negative 1 of x, in other words, the inverse, is indeed the inverse of f of x. So this problem really, and the function, I should indicate, the function is equal to the square root of 3x minus 1. Let's do part 1. Part 1 is to find the inverse. Find f negative 1 of x, which is the inverse. So the way we do that is to let y equal f of x. The second step is to interchange the x and the y. So x is equal to the square root of 3y minus 1. And I'm going to turn it all around because I find it personally easier to do this. The next step is to solve for y. Okay, so the square root, makes it a little bit more difficult. But what you do is you square both sides of the equation. You get 3y minus 1 equals x squared. And now you just solve for y. Bring over the 1. 3y is equal to x squared plus 1, divide by 3, and y is equal to x squared plus 1 over 3. In other words, let's go back, let's bring it back up here. F of x was equal to 3x minus 1. The inverse of that is equal to x squared plus 1 over 3. This is the first part of the problem. Find the inverse. Find the inverse. And then prove that these two really are inverses. And to do that, we have to show that f of the inverse is equal to the inverse of the original function, and that they both equal x. This is what the goal is. So this is a big question mark. Is this true? So the first thing we do is do f of the inverse. So we take the original f of x. So f of x is the original function, the square root of 3x minus 1. But instead of putting f of x, we're putting the inverse in there. What's the inverse? The inverse is right down here. Here's the inverse, x squared plus 1 over 3 equals the square root of 3 times x squared plus 1 over 3 minus 1. And I hope you could see what's going to happen now. Sort of jumps out at you that these 3's drop out, and you're left with the square root of x squared plus 1 minus 1. These drop out. You wind up with the square root of x squared, which equals x. Good. That means that f of the inverse is equal to x. That's what we want. That's what we want. We want, going back up on top here, we want this to equal x. And that's what we've just shown, that half of it works. Now, the second part is to do f negative 1 of f of x, meaning we write the inverse, which was going back up on top here. Here's the inverse that we found, x squared plus 1 over 3, x squared plus 1 over 3. And instead of substituting x, we substitute f of x, which is x, the inverse, x squared, well, wait a minute. So we're putting in the original f of x, right, which is the square root of 3x minus 1 equals the square root of 3x minus 1 squared. See, we're substituting x for the inverse, so that's squared, plus 1 over 3. If that comes out to equal x, that's the end. So when you take a square root of something squared, that comes out to 3x minus 1 over 3. And this drops out with that. The threes drop out with each other, and that will equal x. This means that the inverse of the function is equal to this. Therefore, three dots in mathematics means therefore, we've just proved that f of the inverse is equal to the inverse of f of x, and that they both equal x. And that's the verification. Here's question number 10. That's what we were up to. And if the question is write in logarithmic form. So you're given the exponential expression, and all you have to do is change this to logarithmic form, which means that the log, now you don't need a 10 here. You don't need a 10 because it is a 10, the base, but if it's a log 10, you don't have to put that. So it's the log of 1 over 100 is equal to -2. If you did log of 10, 1 over 100 equals -2, that's okay. So I'll take either one of these. But, you know, in the future, if you take higher mathematics, this is just not what's going on. You leave that out and you go with this one, the log. Okay, number 11 is the opposite question. That's giving you an expression in logarithmic form, and you're asked to change this to exponential form. So you're going backwards. The base to the exponent, the base, this is called the base, this is called the exponent. The base to the exponent is equal to the number. And that's question 11. All right, now we come across an exponential, an exponential equation. So problem 12 is solve for x, 8 to the x minus 1 is equal to 16 to the x plus 3. Now, the idea here is to convert both of these numbers to the same base. So, you know, you have to know those two charts that I discussed the other day, you know, and this would be 2 to the third. So this is 2 to the third x minus 1 equals 2 to the fourth x plus 3. Okay, so 2 to the third is, so 8 is being replaced by 2 to the third, and 16 is being replaced by 2 to the fourth. Now, once the bases are the same, you set the exponents equal to each other. And you solve that equation. Make this a little brighter. Okay. So, you know, you solve this equation as you normally would. 3x minus 3 equals 4x plus 12. Bring over the 3x. -3 equals x plus 12. Minus 12, minus 12, and turn it around, x is equal to -15. Let's go on to question number 13. And again, solve for x, so a bunch of equations. Solve for x, 7 plus 3 to the x plus 4 is equal to 18. All right, so let's bring over the 7. 3 to the x plus 4 is equal to 11. Now, we discussed something on Monday called the change of bases. Let me write that down. Change of bases. And that tells us the following, that this can be converted to x plus 4 equals the log of 11 divided by the log of 3. That is your next step. You go from here to here. Then, of course, you want to get x by itself. So your next step is to bring over the -4. And you wind up with x is equal to the log of 11 divided by the log of 3 minus 4. So we want to figure this out. Let me bring it over here. I don't want to work down. Well, let me work down there. Because there is more. Well, no, let me bring it up here. Log x equals the log of 11 divided by the log of 3 minus 4. All right, so the way to do this problem is to take your calculator, clear it, put in log of 11. You'll get, it'll look like this, log parentheses 11, close the parentheses, put a division sign, divided by the log of 3, close the parentheses, and you could put -4, but I wouldn't, because the calculator will assume that the -4 is being in the denominator. So in my opinion, the way to do this is to just get an answer here. So you press equals, and you get 2.18. Actually, 2.18266. Round it off to the nearest, let's say 100th. Let's do the nearest 100th. It's 2.18. So this becomes 2.18 to the nearest 100th minus 4. And you work this out by subtracting 4 minus 2.18. This is how you do it. All right, so, you do a regular subtraction problem. Okay, so it's 1.82, but recognize that this is a positive, this is a negative, and you always go with the sign of the higher number. Therefore, the answer is negative 1.82. And that's the answer to the question.
Professor, is it okay if I round it to the nearest 10th?
You know, that's a good, I was just thinking that. Who asked that question? Andrew?
Yes,
Well,
Lewis.
Lewis. You know something? I said to myself, when I was teaching this on Monday, I was doing to the nearest tenth, and all of a sudden, I pulled the rug out from everybody and say to the nearest hundredth. That's okay, you know? Yes, this is great, everything is wonderful, but when I was doing this problem with you originally, I was doing it to the nearest, uh, I was doing it to the nearest, tenth. So if you want to make 2.18 equal to 2.2, yes, that's fine, that's fine. And the answer
All
would
right.
be 1.8, negative 1.8, that's fine. No,
All
no.
right. Thank you.
Yeah, that's a very, very good, who is that, Lewis?
Yes. Yes, Lewis.
Lewis, you're the master of great questions. When I give you a final grade in about a month, I'm going to be saying to myself, Lewis always asked great questions. And that was a great question. Because I'm sitting here looking at this and saying, wait a minute, that's not what you told them on Monday. On Monday, you were saying, you know, let's do it to the nearest tenth. Now you're saying to the nearest, I don't like doing that. So yes, nearest tenth is fine. So in other words, it would have been really 4.0 minus 1 point, whoop, 1.8, excuse me, 2.2. It was 2.2, right? So 2.18 became really 2.2, rounded off to the nearest 10, and then 1.8. Okay, and remember, just remember that the 4 is the is you know is the negative, so it's going to be negative 1.8. That's fine. Yes, good question.
Professor,
Yes,
I have negative 192. 92.
193 subtracted wrong.
No, the last answer.
Here, here,
The top one.
here, here,
The x equal,
here,
yeah.
here.
Yes. But what I did it separately. I did log 11 first and then log 3.
Yeah, and then you divided them?
Yeah, and then I subtract negative 4.
Oh, yeah, you're gonna lose. Each time you do something like that, you lose a little more accuracy. So you did the log of 11, got an answer. You did the log of 3 and got an answer, then
Yes.
divided those two, and then,
Yes.
yeah. I would say, okay, I'm saying, okay. Yes, that's fine. If you
Okay.
did that, if I saw that on your test with the work all worked out, you know, if everything is worked out and it came out to that, I would say that's fine. I don't think, yeah, I think that's good.
Okay.
Okay, I understand what you did, and that's, you see what happens, Kariatu, is that each time you do something like that, you lose more and more accuracy. But I mean, you know, if you're in an astrophysics class someday and you want to, you know, figure out like how to fly a spaceship to the moon, you can't do stuff like that because each time you do something like that, you lose a little accuracy, and that's not good. So I would say don't do that. But in this class, you know, that's okay. I'm not going to mark that wrong. Look, when I mark this test, when I mark any test, I guarantee you, and you know this already, we've taken 2 exams, I'm going to look for points to give you, not look for points to take away from you. I want everybody to do better and do well, And that's what I'm going to do. All right? So, okay, that's fine. All righty. Anybody else have a question? Expand using the properties of logs. Okay, so the first step in doing this problem is to convert the square root to that using a fractional exponent. That's the first step. Now, the next thing we do is we put this in front of that 1/2. And now let's do one at a time. The log of a to the 5th plus the log of b to the 2nd minus, see, when they're multiplied, it's a plus. When they're divided, it's a minus. And this becomes 1/2 5 times the log of a plus 2 times the log of b minus 3 times the log of c. Question number 15. Solve for x. Log to the base 2 of x plus log to the base 2 of x plus 4 equals 5. So what we have here is a logarithmic expansion. This is an expansion, and we want to compress it. We want to change from the logarithmic expansion. This is a logarithmic expansion up here. What we did here is called a logarithmic expansion because we took this and expanded it to look like that. In this problem, we have the expansion. Now we want to make it compressed. So this would become the log to the base 2 of x times x plus 4 equals 5. Keeping in mind what I keep saying, that when it's a plus, it means multiplication. All right, so this started out as a multiplication problem. And from here, you go to x times x plus 4 is equal to the base to the exponent. So you're writing it from a logarithmic expression to an exponential expression. And you wind up with, I mean, you could do both, you could work with both of these sides at the same time by saying x squared plus 4x is equal to 32. And then bring over the 32. You can see it's a quadratic equation. So you want to do this. Now, remember when we have fractions, we don't want the denominator to be 0. When you have logarithms, you don't want the log of a negative number. So we have to watch out for any value of x that will make this the logarithm of a negative number. So let's go about our business, though, and let's solve the quadratic equation. That works. Excuse me. Or excuse me, I just dropped my pen and I have to get it. Just gonna leave it out. gonna dry up and that'll be the end of it. Okay, so x minus 4 equals 0. We're solving a quadratic equation. And x is equal to 4, and x is equal to -8. This is the problem. The problem is right here. You cannot have the logarithm going back up here of a negative number. Therefore, this is extraneous. Now this works, the log of 4 and then 4 plus 4, that's fine. The answer to the question is x is equal to 4. And that, ladies and gentlemen, will be your test.